Hello everyone. So my name is Daniele and I'm an Android consultant. I've been working with Snapp Automotive for the last couple of years, and I was able to work on several automotive projects. One of which is this proof of concept that I made for COVESA, which is for, as Chris correctly mentioned, an Android Automotive SDK. But what is it, COVESA, first of all? So COVESA, it's, as the name suggests, a connected an alliance of manufacturers of vehicles, which aim to create, basically to improve the development of connected systems for cars. It's not only composed by car manufacturers, but there are other entities that are inside this alliance, namely software developers, agencies, app stores, and all different parties that are interested, let's say, in some collaboration around the topics of improving how systems on wheels are going to interact with each other. So let's put it like this. So the scope of this SDK that I started building was to create an abstraction between some service that could be provided by car manufacturers and a way to interact with those services by app developers. Ideally, we would have two main components. One, which is running on the actual car and exposes some kind of functionality. So imagine the state of the engine, speed, current AC temperature, heating for the seats, and all different kind of data coming from the car. And then a component that could be integrated in third-party applications. Now, if any of you already worked with Android Automotive, they know that there are already some things that are called car properties or vehicle properties that a third-party application can access if those apps are running in Android Automotive. Those are, however, a bit, let's say, they don't have a great API for developers. So having to modify a third-party application to access those can be cumbersome. And we know that to avoid, to have as many developers to, let's say, start using a new service, we need to get to make their life as easy as possible. That's the reason, one of the main reasons for this SDK. So the components here, as you can see, as I mentioned, there are two components, client and service, and in the middle, some sort of communication. For this proof of concept, I went for the industry standard, at least for Android interprocess communication, which is the Android Interface Definition Language, or ADL. That one is an interface that allows different applications, different services, basically to communicate by exposing some data and some methods that can be invoked remotely. And the scope of this proof of concept was a simple use case, which is basically to create a controllable light service. In this example, third-party apps could set some interior lights for the car, selecting in which zone to turn on or off. So, for example, just for the driver, the passenger, all the front lights or the rear, etc. Through this SDK, they could change the color and the brightness, and of course get updates about the light statuses. This is pretty important because in a modern world, we want the UI of third-party applications to be reactive, and also to consider that the car should be the only source of truth, because the app is not going to be the only element controlling this kind of lights, but some updates, they could come from actual hardware switches, or maybe opening the door could trigger automatically some sort of light, and that should be reflected also in the application. Then we also want to be a bit future-proof, and so that the client application could also need to know the version of the installed service in order to know which methods are available or not. So what we provide with this SDK at the moment is, first of all, for the app developers, we provide the ADL definition, which is needed to actually connect to the service. An AAR, or actually multiple AARs, to actually encapsulate this into a single dependency that could be injected and added into a Gradle, and so this is just for easier implementation by the third-party developers. Some samples, some code that, as we will see, it's completely open source. Some documentation, which you can see a screenshot on the right here on this slide, and a service implementation. This service implementation is particularly important because I created a mock version of the service, which will basically react in a realistic way whenever it receives a connection from a client, and also it receives some method invocations. It's important that this service is gonna be able to run in any emulator, not only in automotive emulators, so that, for example, developers, they can test it even on a tablet or on a regular phone if their app is behaving correctly. This is to make, again, developers' life easier, and also to allow them to quickly verify their implementation against a certified version of the service.
Hello, Daniel.
Yep.
Are you sharing your screen?
Yes.
Yeah, but it is not visible.
Oh.
I can see it.
It's working for me.
Yeah,
me too.
Yeah, me too.
Yeah. Okay.
Then it might be my issue. Okay, sorry.
Yeah, sorry.
I'm
Maybe
afraid it probably is.
Yeah, try to restart the Zoom. I don't know. Sorry.
Yeah, it's okay. No.
Okay. So speaking about some of the implementation details, this is the current version of the ADL for this light remote service. As mentioned, it gives an API version, which is at the moment is just static, just one, and then it has let's say three main methods. One is to basically set the internal light with a parcelable object, which is light state, encapsulating what I described before, so the zone, color, and brightness. Then a third-party application can register and unregister a listener to get notifications on whenever the light status changes for any of the zones. ADL, I mean, as I mentioned, is a proven concept. It works. It's powering a lot of services in the Android world, but the API is not great. You need to create a service connection. You need to bind to this service. You need to implement a binder. You need to listen to a lot of service connection callbacks, which are not really the scope of the actual case that we want to cover here. What we want here, we want to be able to change lights and get notified when some light changes. A third-party developer should not care too much about the implementation details for this connection. For that reason, I created another abstraction layer, which is basically simply exposing these functions. Just a Kotlin flow of list of states, each one for each zone, and two methods. one to get the API version and one to set the internal light. That's it. Third-party applications, once they included the dependency, the Gradle dependencies they created, they could simply use this light service client and in general just get subscribe to this flow, get updates when they receive it, and invoke a suspend method to set the internal light. And the rest is hidden under this interface. Okay. Moving then on the car manufacturer's point of view, what we created is, again, another similar library to the one that is available for clients. So it includes the same ADL definition, which is used to create the service in this case, an AAR, something that I mentioned before. At the moment, the library is only in an AAR format, but that's temporary, hopefully. In the future, it should be hosted in a proper Maven repository, as it should be. Again, some samples, which coincidentally, the sample for the car manufacturer is the one that was used by the client to verify their implementation, and vice versa. Car manufacturers, they could use the sample application that was made for third-party application developers to test their implementation here. Again, the service example is pretty simple. Like in this case, we just have the binder to be implemented with the different methods. One, to check when listener is registered or unregistered, and to react when set internal light is invoked. In the mock version that is in the repository, there is a list of current lights, which is the one that gets propagated to all the registered listeners every time that set internal light is invoked. Again, pretty straightforward, but something we need to remember here, and I'm going to say it before the end of the talk again, is that this one is just a proof of concept at the moment. It's not meant to be a production-ready service. It's more like a starting point for discussions and to evolve and to see if this approach can be used for other services or other use cases in the future. Then there is also an extra service, which is basically what I call the services catalog. Sorry. This one is a very simple service that just at the moment returns the light service and its version, but this one is just because it's the current one. In the future, this would be expanded to include more services. And the idea is that with this one, a third-party app developer, a third-party application can know which services are installed in each car, basically, where the app is running. And depending on which one, they would know which methods are available. At the moment, this is just one, but again, we want to keep this as flexible as possible so that more services can be installed, but each car manufacturer can have the flexibility of, first of all, which one to implement, and second, how to implement it. Because something I didn't mention before is that, of course, depending on the car model, some cars, they can have just a single light that can be triggered for the all zones. Some others, they can only trigger light, allow apps to trigger lights or on or off, while others, they can also control the lights using RGB values. So that's dependent on the manufacturers, but it should be totally agnostic for the third-party applications. And this is one of the steps, one of the building blocks. Sorry. This is one of the reasons why I also created this service catalog, so that third-party app developers, they can just query at runtime what is installed and what's available or not. As I mentioned before, all the project is totally open source. This is the URL of the repository in case you want to have a look, and it's pretty basic at the moment. Is basically what I just shown, but in case you are curious about the implementations, here you can find everything, and also the releases with the AAR and the documentation. Again, this is just the beginning. There are some steps that I would like, if I have the time, to work on, or I would like everybody feedback about. For example, in the services catalog, to get the version for each installed service and a flow of installed services, while at the moment it's just responding to suspend method. It would be interesting to get notifications when a service is installed, uninstalled, or even updated. In general, the approach that I try to follow is similar to the one that Google does for the Play services, basically, where third-party applications can basically consider those as available and do not worry too much about the implementation details. Then there are, at the moment, only happy paths are covered. It would be nice to have a better handling for not available services, errors, errors management, exceptions management in general. And then, as I mentioned before, also deploy the libraries artifacts to Maven repos for ease of integration for third-party applications. Finally, given that this one is, first of all, a proof of concept, but it's an evolving project, the repo is open source, but also it's open for pull requests, issues, and more importantly, discussions. This is something that with other COVESA members would really try to encourage, to have a broader discussion and to have also feedback from the community in order to see, okay, this is a good approach, can be improved, this has some bad consequences that maybe we didn't talk of. Again, totally open, so all feedback are welcome. And with this, I end my quick introduction, so thank you all for your attention.
Okay, thank you very much for that, Daniele. Anybody have any questions? Sven Falk, I think was. Oh no, so you're applauding.
Yeah, I was clapping. Do you hear me? I have some trouble with the audio.
Yeah, yes,
Yep.
it's fine.
Sounds good.
Yeah, I was just clapping, but I also have a question, so it fits. Danielle, do you also cover the situation with multi-user? Because we are in a project also with AOSP with a customer, and user switching is kind of a trouble, especially for services we have developed on our own, doing similar things that as you do with your SDK. I find it quite interesting, and also with flows and coroutines, a good approach. But we have kind of a hassle with user switching because services are running twice then for a couple of time while the user switch happens. Do you have ideas how to tackle that?
That's an interesting question. No, I didn't check it with the SDK at the moment. I had some experience in the past. I think it really depends on where the service is gonna run, or better, on which user the service is gonna run, and which permission the service can use. If the service could be a system service with interact across user, or I don't remember what's the name of that permission, maybe it should have more power. Let me use this term, and to be able to work on to interact with different clients on different users. But honestly, I would need to test it to be sure, because it's not an edge case in general, but I don't have the answer ready yet.
Yeah, no problem. Yeah, we are on the same track there. So basically what we did is if we can move to user 0, so the system user, we move to user 0 so that we do not have running services for all the users twice or how many. But yeah, that's, as you said, kind of then maybe an issue with security reasons or with, yeah, how do you say that, with customer regulations. They maybe do not want to have much user 0 stuff running at all and stuff like that. This would be an interesting discussion maybe.
Certainly,
Yeah,
I
exactly.
would.
Yeah.
Sorry.
No, please
I
go
was just to
ahead.
say that the user 0, the so-called headless system user, is exactly where you should run these kind of things, so you don't have multiple instances per user, because there can only be one instance of user 0.
Yeah, of course, but it depends on the use case. So if you have a very central use case where you say, okay, this is really viable for or really valid to have it for all users in a central place, then it's okay. But you then have to have special permissions and stuff like that. And yeah, and this is then also depending on the implementation of the SDK. If they allow it or not. Maybe some do, some not, and yeah, it's kind of difficult with that stuff. That's my feeling in the project. I'm not sure if that's in every project the case.
I was going to ask you, Danny, about permissions. What permissions do you need to use these APIs?
So at the moment, we didn't touch anything about the permission. So that's definitely some work in progress for the future to restrict a bit the usages for this for the SDK. At the moment, we don't need any permission.
Okay, so this is available to third-party apps then?
Yeah.
Okay.
But just to be clear, at the moment, the actual implementation for the lights is just a mock implementation. So that's the thing. Like each manufacturer should create their own implementation to actually interact with the hardware. That's the reason why if there is some permission management, it should be made into that service implementation. But of course, it should be propagated also to third-party checking, that only third-party applications that are verified by the manufacturer could handle it. So that's still a work in progress.
Okay, cool. So, for example, if the manufacturer were to implement this using, for example, a vendor property, then that would require the whatever permission it is that you need to access vendor properties. Yeah.
But that one should still be made in the service side.
Gotcha. Yeah, that makes sense.
Because third party app, it doesn't matter if it's through vehicle properties or through a third party SDK or through some I don't know flag in the hardware. It's abstracted.
Okay, makes sense. Sven.
Yeah, thanks. Also to permissions. The same thought, Chris. So I could see that, or is there the possibility that manufacturers tend to pass those permissions through, so that they say we want to share only with a limited set of apps APIs and not with everyone, so that there's still some kind of permission mechanism. So I could imagine that this is the case, because maybe you don't. So going back to the light example, you maybe do not want to have every app access to the light state, right?
Yeah, absolutely. This is something that could be explored in the future, but also something that I can imagine being implemented in the service implementation, like on top of the common APIs that are exposed by the SDK. The service could make some more checks, let's say, to do what you just described. Yeah.
Vinod, you have a question?
Yes, yes. Yeah, just small question that see, we have the AOSP, AOS already. There is a light service, right? Okay, it's a basic implementation. But what is the difference between this and one more question that the if suppose the OEM can use this particular SDK, there will not be any need of different HAL service implementation, Daniel?
I didn't get entirely the difference between this and which one?
The AOS already providing the AOSP providing already the light service, right?
Yes,
For
yeah.
automotive. So what could be the difference basically, because that is also part of the SDK in the when Google is releasing, right? So what is the major difference here? That is one question. The second part of the question, like when you said that we can use this SDK for OEM, they can implement their own. Okay, in that case, there will not be any HAL service implementation is needed for this.
Yeah, exactly. So, so as you mentioned correctly, there is already an implementation, or there might be for this one, but this is more a proof of concept. Like the light was chosen just to have a very simple use case to test this communication between some service that stays that lives in the car and some other application that is outside. Again, it's just a proof of concept. So there could have been, instead of this one, we could have used, I don't know, seats heating or the drive wheel heating, or I don't know, some other properties that maybe are not present in the VHAL, but that could be exposed. Again, this is just an example. And the second part of the question was if it was not if it was implemented, if there was no need to implement in VHAL.
Yeah, correct.
Yeah, in that case, it's just up to the manufacturer. So
Okay.
again, this one gives flexibility for both the client but also the manufacturer to implement their service whenever they prefer.
Okay, if I understand correctly, this is the framework service, not the application service, so that the third-party application can use this API to get the right?
No, well, this third-party application, yeah, they can use it as a third-party library, but it's not in the Android framework.
Okay.
This one, it's still in a user level.
Yeah. Okay. Thank you.
Welcome.
Okay, Johan?
Yeah, it kind of ties to Kamal's question, but it's so what are the major benefits you see with this compared to the core API? I mean, it feels kind of similar. I agree that the core API is not maybe the easiest to use, but it's still included already in Android. So what will be the biggest pros, and what kind of drawbacks have you seen so far with the proof of concept?
So at the moment, as I mentioned before, is more like a discussion starter.
Yeah.
So it's not something that is production ready at all. And the biggest advantage for me is the more ease of introduction of implementation, by third-party application developers, and also to have a better API basically. Then what I'd like to see is also the implementation of more services, which are not only controlling some data in the car, but also maybe having more advanced communication. So, for example, with more cars or with more remote services, but they can be accessed through a single SDK, so that for example, third-party app developers, they can control the whole ecosystem of the car from a single API or a single set of APIs, instead of having to deal with different APIs scattered around the whole SDK, the whole framework.
All right. Yeah, I can see a point in it.
So if I could just jump in there a little bit, because I've done a little bit of kind of liaising with the people in COVESA. The problem is that all of the auto manufacturers are coming up with their own APIs to do extra bits and pieces. And so the key idea here is standardization, so that there is a single SDK that can be shared between BMW and Ford and General Motors and whatever, rather than having a separate SDK for each individual manufacturer. Is that fair, Danny?
Yeah, absolutely. Yeah, that's a very good point.
So this is just the start of that. And I would like to ask, actually, have you had any from the various auto manufacturers that are part of the COVESA alliance? Have you had much feedback from them? Have you had any ideas as to what further APIs they would like to add to this system?
I have to be honest, unfortunately, not yet. So yeah, let's hope that in the next months the discussion is gonna resume again.